Bismillahirrahmanirrahim. Okay guys, welcome to next part of the electrical machine, which is induction motor part 1. So we have induction motor in terms of part 1 and part 2, which is part 1 will focus on the 3-phase and part 2 will focus on the single phase. So why we start with 3-phase? Because in terms of the sequence or the operation of induction motor will be more preferable or can be seen in terms of their operation in 3-phase mode rather than single phase. So it's easier to see the sequence of the operation of induction and in this 3-phase. So that's why we start with 3-phase. Okay, for this subject or this syllabus of a 3-phase induction motor, we shall go through in terms of the construction of the motor, theory and operation, torque speed characteristic, same per previous motor, how the characteristic of behavior of the motor, the starting method of this 3-phase induction motor, and how we can perform the speed control of the motor, and calculate in terms of their efficiency in terms of their output power versus input power, their power flow diagram, and etc. Okay, induction motor in terms of their usefulness is that they are, in terms of comparing to the DC motor, their construction is much simpler, and because in DC we have some sort of components which involve brushes, commutator. So in this kind of induction motor we don't have such as extra component. So it was comparing to the DC motor, it's considered as a cheap constructed motor elements. So we need lesser in terms of maintenance because we don't have to put effort on the brushes changing or commutator servicing. In terms of size, same size will perform in terms of same or the output power. Okay, due to the advantage of this induction machine, was become much popular compared to in industrial application. So when you have a visit on the industrial, such as factory, machineries whatsoever, which needs more motors or many more motors on their operation site, so they prefer to have in terms of AC induction motor compared to DC, because we don't have to focus on the servicing the motor regularly due to in terms of changing their brushes, cleaning their motor and whatsoever . Okay, this induction machine also is known as a synchronous machine because it will speed or will not run per frequency or the speed of the line voltage that's applied to the motor, but in terms of reduced speed compared to the induced frequency. So asynchronous means that the rotor rotates at the speed less than the synchronous, compared to the synchronous machine, which is the speed of the rotor which is equal to the speed of the stator magnetic field. Okay, in terms of construction we have same part, which is stator and rotor. Stator referring to the core and the slot of the winding, which is fixed on the stator side and outside of the rotor. So we have here rotor. So for the stator we have two kind of connection for 3-phase, which is delta connection, or we have connected between line to line, and we don't have any neutral connection, and we have star connection, and line to the neutral, from line to neutral, and this neutral will connect to the the neutral lines or the rings. Later on you see the connections. And we have a rotor, which is the core and the slot, the winding on the bar, slip ring, brushes. And for induction motor, we have two kind of rotor construction, which is squirrel cage type or wound rotor type, and SEIM or WRIM. So we have two kind of rotor construction for induction motor. So same for single phase and three phase induction motor, we have same kind of stator, and we have windings here. If let's say we have three phase, so one phase will contribute 2 poles, and so we have here, if three phase, we have minimum of 6 poles. So squirrel cage rotor versus wound rotor, they have the same both type of rotor construction. So this is the example of squirrel cage. We have here conductors of aluminum bars. We have here also in terms of wound type, they are bars of iron bars here. Here we have usually in terms of aluminum bar. Here we have iron bar, and we have a laminated iron wires or iron core and connected to the ring. So this construction of wound rotor, we have external ring. This is not a commutator like the DC commutator which are connected to the brush. This ring will be connected to the external resistance element. So as what we have learned before, when we manipulate in terms of field current or field voltage, and so we are able to control the speed of the motor, like we learned inside the DC arrangement of the separately excited DC motor. So this is the same application to the induction motor. Okay, we see that application of this slip ring later on. Okay, we have squirrel cage rotor, which is squirrel cage refer to the, actually it's not squirrel, actually it's if you can see it from the aquarium or the pet shop, we see the it's not squirrel that run into the inside the cage. It was a hamster instead. So by that they should name it as hamster cage lah, but I'm not sure why they put it squirrel cage. So this rotor is has a laminated iron core with a slot, and it is mounted on a shaft. And we have a iron core on the slot mounted on the shaft. So the aluminum bars are molded and in the slots, and the bar are short circuit with 2 end rings. So this is most of it are the slots made of iron bar and from the aluminum bar. So this is the end ring of the slot, which short circuit all the iron the aluminum bar just now. So the bar is slanted and on a small rotor to reduce audible noise, and we skew a little bit on the bar such that we don't have what's called a hiccup on the motor when we run on the circuit. And the fins are placed on the ring that shorts the bar. This fin works as a fan to improve the cooling. So end of the bar we have a fin actually. So the fin is made like a fan to circulate the air within the rotor, such that the heat that generates within the system is dispersed to the ambient. So we have another construction of wound rotor. So wound rotor, as I told you before, we have here the external armature, the field circuit to generate field north and south pole, and we have here internal windings on the rotor. You can see here the internal winding on the rotor connected to the ring. So internal winding connected to the ring. The ring is connected to another external resistor. So this external resistor is used to limits the current that flow into internal rotor element or rotor skirt. Okay, the three phase of rotor windings usually are Y connected, and rotor here are Y connected lah, because we need to connect to the external resistor and the internal ring. So the end of three rotor wire tied up to the slip ring. So tied up to the slip rings on the rotor shaft, and see here we have here three external connected to the external resistor. So the ring dot here connected to the ring, external ring connected to the Y connected here. So resistor of the power supplies are connected to the slip rings. So either we connect a resistor or power supply to the internal rings, internal Y connected rotor. Connect to the slip ring through the brushes for reduction of starting current. So the main purpose of this construction is to limit the starting current. So most motor use squirrel cage rotor because they're robust and require less maintenance. So compared to the wound rotor, but actually the squirrel cage type is most being used in the factory lah. So in terms of theory and operation, so how can the stator of the magnetic field can be rotated? So it's not actually the we rotate the magnetic field, but we rotate the sequence of switching or sequence of current that flows into the poles. So we have here 6 poles. So one pole, another one pole, another one pole we rotate, will be switched, and it will rotate in terms of your field in 120 degrees in sequence. So the principle is that a three-phase set of current, each equal magnitude and differing in phase of 120 degrees, flows in the three-phase winding. Then it will produce a rotating magnetic field of a constant magnitude. So it will separate 120 degrees apart around the surface of the machine. So let's say if we have here the phase A, phase B, phase C, and A, B, C here. So phase A comes in, we can see the arrow of your current going back up here and going here up and back to the neutral point. So if we use right hand rules, we drag all the wires. So we shall have here the north pole generated on the pole here. This is north and this is south. So north, south. Then when another, so this is when the blue phase goes down, we have a yellow phase goes up. Means that after the, let's say we have here red phase refer to the A. So when A is up, A is down, B is up, and B is up. So the field will change to B. Then the field will change to the yellow, which is C. So it means that you have north here, north here, north here. So the north is turning anti-clockwise. So it means that you are creating a rotating magnetic field. And so we have here A, B, and C, which rotate 120 degrees each other. So this rotating magnetic field will produce a current that, will produce a voltage difference inside your bar and inside your current iron bar here. And the rotating magnetic field will produce current voltage difference between your bars here, and so the current will flows in. When the current flows in, you produce the torque, and we have here the right